Okay, so unit 3, lesson 1. So it's the zeros, as you already know, zeros, roots, and x-intercepts, how they're all the same. I'll kind of speed through this part because it kind of just talks about, well, I won't speed through this part. This part's important, but the understanding is that, remember, x-intercepts, roots, and zeros are all the same thing. Okay, function notation, what does this mean? When they write stuff as f of x, okay, that means a function of x, and it's another way of writing y. Okay, so function of x is the same thing as y. And so they'll write things like right here, this is function notation. F of x is 4x minus 8. If they want to know what f of 5 is, that means they want 5 to be x. Okay, and that's function notation. All right, and then here's the y example, same thing. Okay, and then real quick too, let's talk about what a function is. Okay, a function is each element of the domain is related exactly to one element of the range. Well, what the heck is domain and range? Well, domain is your x, range is your y. So, like, you know, if I have a graph, I have a table of x and y's, right? Okay, and what this means is that every x can only go to one y. So if I have 0, 1, 2, 3, and I put another 2 here, these 2's have to go to the same thing. So I can't do 2, 1, 0, -1, -2. I can't have a 2 go to -2 and a 2 go to 0. That's not allowed. So another way of saying it, every x can only have one y. Okay, that's just kind of functions. Okay, and then here's some more just about the function notation. So again, they're just plugging f of 2 in. They got 0. I mean, it's the same thing. All right. Oh, no. Oh, wow, this thing really is touchy today. Ooh, we're on lesson 2. Okay, so I'm right here. All right, so investigation 1, so connecting the roots, x-intercepts, and zeros. So the next investigations we're going to go through explaining why they're the same. Okay, so the graph of y equals 2x minus 6 is shown. So this is the linear graph, 2x minus 6. Okay, you can determine the x-intercept using algebra and algebraically. So we can use the graph first. The x-intercept's right here at what? What's that? 3, right? Okay, so I know it's by the graph, it goes through x equals 3. Then it says it wants to determine algebraically. Well, algebraically, when you want to find x-intercept, what do you make 0? Y. Good. So I'm going to make this y 0. I'm going to solve for x. 6 equals 2x. Divide the 2. So again, you see we get that same 3. So we just proved that you were right from your picture. So the picture says it's 3, and when we solved, we got 3. How that line is? Yeah. Okay, so are you familiar with linear graphs in terms of the 2 being the slope? Do you remember slope from grade 10? So 2 is the slope, and that's what you rise, so you go up 2 over 1. -6 is where you start. So that's why this starts at 1, 2, 3, 4, 5, 6. It starts down here at -6. And so look, watch. 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. I just kind of have a bad counting there, but it just goes up 2 over 1 every time. Okay. And so that's what makes it linear. Okay? So determine the root of the equation. Well, the root of the equation is the same thing. So we'd add 6. They're doing this on purpose. 2x is 6. We get x is 3 again. So it's the same exact situation. Okay? And then it says state the connection between the x-intercepts of the graph and the roots. What's the connection between these two? They're the same. So that's all we're doing. That's all we're writing here. Okay. going here. Whoops. All right, and then D. Consider the function f of x is 2x minus 6. What's the 0 of the function? That's the same thing. I'll just do it really quickly, but it's getting tedious now. You said 0, like I already did. 6 is 2x. X is 3 again. So the 0, the root, all of them are the same. Okay. All right. Now, is there any questions on that? Okay. It's kind of a little bit tedious in this lesson, I remember. Oh, I'm going to kill this thing. Okay, so investigation 2, it gives us a quadratic now. And this is important because this is what our, we're going to be dealing with this chapter, parabolas, right? So, Jacques wrote the determining roots x squared minus x minus 6 equals 0. So he wrote the equation in factor form and used the zero product law to determine the roots of the equation. So what is this factored? What are multiples of 6 that are 1 apart? 2 and 3. And since that's negative, which one's negative? Yeah, so it's going to be x minus 3, x plus 2 equals 0. And so this means what's 0? Yep, negative 2. Right? So we feel good about that. And so then if I move up and look at the picture, we should expect 3 and negative 2 to be where that parabola crosses. Good Lord. What page is it? Wow, this is not good right now. Yeah, I gotcha. All right, try that. Okay. All right. So this is the graph shown, and so we can see, like you just told me, x is negative 2 is an answer, and x is 3 is an answer from the graph. State the connection. They're the same. Explain the connection between the factors of x squared minus x minus 6 and the roots. Again, they're the same. And that's pretty much the basis of it. Just understanding that any time that we're trying to find roots, if we have to factor, then we have to do factor to the zero product. Okay? And so then we get negative 2 and 3. All right, and what's the last part I want us to do here? It's probably going to be some more repetitive stuff about how it's a 0. Okay, consider function x squared minus x minus 6. Determine the zeros of the function. So to determine the zeros, we make that a 0. And then we'd factor again. And we get the same thing. And then down here, it's what's the connection. They're the same. Very redundant. I think you probably get it by now in terms of that piece. Okay, so let's move on to hopefully, I think we have one more example. Oh, okay, so fill in the blanks of the following statement regarding the function with the equation y equals f of x. The blank of the function, the blank of the graph, and the corresponding y equals 0 are all the same numbers. So I would say the zeros, the x-intercepts, and the roots are all the same. One more time. Okay, and so then this graph here is just the same one we were just doing. So your x-intercepts are what? Your x-intercepts are negative 2 and 3. Your zeros are negative 2 and 3. And your roots are negative 2 and 3. This is just trying to hammer home when you're reading a test. If it says find the roots, that means find the zeros. What's your y-intercept? Negative 6, right? Good. Okay. All right, so consider the equation 2x squared minus 7x plus 3. Describe how the zero feature of the graph calculator can be used to determine the roots. Do you remember the zero feature? Nope. All right, let's talk about that. Use my calculator here. I'll bring up my calculator. Okay, let's get the calculator loaded. Okay, so we want 2x squared minus 7x plus 3. So 2x squared, so go to your y equals. It's the first thing you're going to do. Just clear everything out of there. You're going to put in 2x squared minus 7x plus 3. You good? Yep. Okay, then you're going to hit graph. Let's see what it looks like. Okay, so there's my graph. Okay, and so we want these 2 points. Those are my zeros. So you hit second trace, and you're going to select the function 0, which is number 2. Okay? So now it says left bound. Now see where my cursor is flashing there? I'm not sure where yours is. But what I like to do is I like to move it close to, I'm going for 2 spots. I have to do this thing twice. So I'm going to go for this one right here first. So I'm going to get close to that. Okay, I'm pretty close to it right now. And it says left bound. Okay, so I'm going to hit the left key until I'm well past it. As long as I'm past this spot right here. Okay, so I'm going to hit left, just keep going. Okay, I'm definitely past the 0. I'm going to hit enter.
Once you get to that first spot, you press enter?
Yeah. And so it says right bound. Did you just say right bound? Or are you doing it right now? Okay. Okay, now it says right bound. Now I'm going to click until I pass the 0. So somewhere down here where I'm on the right side, or hit the right arrow. Right, till I pass the 0. Okay, I passed it right here. I hit enter, and then it says guess. Let me just get somewhere close to it. And hit enter. And then it zeroes in on the answer. So you should get 0.5. 0.5 or 1/2 is your answer. Okay, so go ahead and try the second one. So with the second one, we're going to go second trace. We're going to do it again. And we're going to move over to the other side to try to find the other 0. Okay, so I'm close to it. I'm actually pretty right on it. I'm going to move left a couple. So I'm left of it. Hit enter. I'm going to move right to it. Hit enter. And then get close to it. Hit enter. I got 3. Yep. So that's how you use the 0 feature, okay? So we did that. We saw that our graph was, we got 0.5, and we got 1, 2, 3. Our y-intercept is at 3, so our graph looks something like that. Okay, we did that. Use x-intercepts. Okay, 2x squared minus 7x plus 3. So we did that. So to factor the expression, we have to do our decomp, which you know how to do. That'd be 6. Factor the 6 add to 7, be -6, -1. I'd go 2x squared minus 6x minus x plus 3. Do my grouping. I'm just factoring right now is all. Pull out a 2x. Pull out a -1. Oops. Minus 3. And so we get our factored answer is 2x minus 1, x minus 3, which makes sense because that 0 is 1/2, which we got 1/2 right here, and then this 0 is 3, and we got 3 right there. So they're all related. Okay, you good with that? Cool. All right, let's see if this thing's going to be nice to me. So what are the zeros of the function? 1/2 and -3. Excuse me, +3. Okay. All right, so finding zeros of function. Find zeros of function, f of x, either substitute a 0 for f of x or make your y 0. Graph the function and use the 0 feature. Determine the x-intercept. So whenever it says find the zeros of function, you're looking for the x-intercepts on the graph, or you're trying to do the 0 property with factoring. Okay. All right. Find the roots algebraically. So find the roots of the following equations algebraically. So what we're going to do is the first thing we want to do, in order to find roots, we have to have one side equal what? 0. Good. And that's a 33, not a 0. So what should I do? Just move it over. So I'm going to minus the 33 over. So now I have this. Now I'm going to try to factor that. Okay, factors of 33 that are 8 apart is 11 and 3. So it's going to be x plus 11, x minus 3. So then what are my zeros, or my roots? Positive 3. Yeah, negative 11, positive 3. Good. Okay, part B is already factored for you. Okay, you don't have to, don't, I know when you first saw it, you probably thought I should FOIL this out. We don't want to FOIL it out because it's already good to go. What's this one's answer? That's the easy one. Positive 3. And then you remember how to do this one? Negative 5 over 4. Because you're going to minus a 5 divided by 4. Okay, good. And C. It's already said equal to 0. What can I do? The 6, only if it's a 6x. If it's just a 6, it's not, there's nothing, there's nothing. Okay, what can I pull out here? Just 2. Right, they both have a 2. So that gives me x squared minus 4. Does x squared minus 4 factor? 2. Good. So your answers are? Negative 2 and positive 2. And that's where they cross. Good. Perfect. All right. All right, and find the zeros, find the y-intercept of the graph. So I want to find the zeros and the y-intercept. Now, whenever it's in general form, and we're going to talk about standard form and stuff later, but whenever it's in general form, the constant, like I was telling you earlier today, that is the y-intercept. So right now I can just put my y-intercept is negative 20. Because how do we find x-intercepts? We make what zero? Y, right? How do we find y-intercept then? You make x0. Now if I make x0, these two things go away, and just negative 20. So my y-intercept here is what? Positive 10. Yeah, it's normal. Okay, and then this one we can't see it, and it's actually, because I'm going to multiply those, it's going to be 0, because there's no constant. So if I multiply these, I'll get 4x squared plus 2x. There's nothing out here, so my y-intercept is 0. And that's general form? This is called general form. Yeah, the thing you did on your project today, that was standard form. Okay, so now what I want to do is I want to find the zeros. So it's kind of ugly here, but I notice they all have a what in common? 5. So let's take a 5 out and see if I can factor it easier. Plus 3x minus 4. Okay, multiples of 4, there's 3 apart. 4 and 1, so it's going to give me a x plus 4, x minus 1. So what's your zeros?
0.
Well, there's no x here.
I mean, no, so nothing.
Right.
And negative 4 and positive 1.
Good. Okay, and this one, I can't GCF, so I have to decomp. So I have to do my 30. Factor 30 is 11, negative 6, negative 5. So here we go, 3x squared minus 6x minus 5x plus 10, group. So I pull a 3x out, gives me x minus 2. I pull a negative 5 out, gives me x minus 2. 3x minus 5 times x minus 2 equals 0. So, what are the zeros there?
5, 3.
Good.
And
Good. Okay. Now this one, I know I multiplied it out, but we're going to leave it like this.
Okay.
So what is that 0? What's this one?
1/2.
Negative.
Negative 1/2.
And then what's this one? There's an x out here now, so like 0. Good. Yep, perfect. Catching on? Okay. All right. We got a little bit more here. All right. So for each of the following functions, use the graph calculator to sketch the graph of the function, find the zeros as exact values, and write the function in factored form. So on our calculator, we just want to go ahead and put that in your calculator and then find the zeros. Okay, so it's 3x squared plus 4x minus 7. So let me do this too. 3x squared plus 4x minus 7. All right, so 3 plus 4x minus 7. Okay, so that's what my graph looks like right here. So let's do it. You got to do your zeros now. Second trace 0, left bound, okay, I'm left bound, enter. I'm right bound, enter, close, enter. Negative 2.3 repeating, so that's negative 2 1/3, or 7/3, negative 7/3. Try the other side. It might have just went really high. Yeah, see it's at negative 14. To me it's way over here, so you want to keep hitting right. Keep making it come down. There. Okay. All right, and the other side. So left bound. Enter. Right bound, enter. Enter. Net 1. So I got 7/3, negative 7/3, and 1. All right, so and this one looked like, so we have 1, 2, so this one went through right about here, negative 7/3, and then went through 1. It looks like something like this. So we found the zeros. This one was negative 7/3, and 1 was the zeros. We sketched it, and write the function in factored form. See, we can kind of cheat now that we know these. We know if it's 1, the factor is going to be x minus 1, and then the other one's going to be 3x plus 7. Yep, good. 3x plus 7. All right, and then we'll try this one. Okay, this one's going to be different. We're not going to do a lot of cubic, but they just want us to do that. So 4x cubed minus 7x, so let's put that in there. 4x cubed, 4x, let's go clear. 4x cubed minus 7x squared. Okay, and minus 4x and plus 7. Okay, so we graph that. So we get that little n, and that's what a cubic looks like. And it crosses 1, 2, 3 spots. So we have to find 3 zeros. So I have to do it 3 times now. 0, okay, I want to be left. So I hit the left. I go past the first one here. I'm going for this guy. Enter. Now I'm going to come up to the right of it, past it, enter. So my first answer is negative 1.
Yeah.
Okay. And then second trace, 0 again. Going for left bound. That's left bound. Oops, left. There's left bound. We'll just barely below it, right bound. And then click close to it. Positive 1, so I have negative 1, positive 1 so far. And my last one. Left bound, enter. Right bound, enter. Close to enter, 1.75. Okay, so we have negative 1, 1, and 1.75. So if I come back over here, sketch the graph of the function, so we know it goes through negative 1, 1, and then 1.75. So it went like this. Okay. And then my zeros of this one was negative 1, 1 and 1.75. 1.75 is a fraction. That's going to be 7/4. So then our factored form would be, what would this one be? If it's a negative 1, positive 1. Okay, and? Perfect. 4x negative 7. Nice. Very good. Okay. All right. I think we're on the home stretch here. Yep, that was it. All right. Good deal.